All right, everybody, let's go ahead and get the show started. Hi, everyone. Good evening. Thanks for being here. Welcome to the virtual Science Cafe. I am your host tonight. My name is Chris Smith. I'm curator for the SCCU Daily Planet Theater at the wonderful and inspiring North Carolina Museum of Natural Sciences. Thanks for joining me tonight. Thanks for tuning in. Glad that you could be here to take in some great science content. We've got a cool show for you. I think you're going to learn something tonight that you didn't know before. At least that's what I hope every week when we host the science cafes, whether it's in person, downtown Raleigh, or right here in your home from mine, not actually in the museum. But that's what we're here to do. We're here to learn something new, have a good time, meet experts, share insights. And one of the best parts is that even virtually, you get to have your say. Throughout the program tonight, I encourage everyone watching to type up your questions, your comments, leave those in the chat box and in the comments. And after the presentation with our guest tonight, we'll actually grab those comments and questions and pose them. So you'll learn something new, and then our guest speakers can learn what you want to know more about. It's a cool back and forth thing that we do as part of the Science Cafe. Makes this, fun and hip and interactive. At least we hope so. So that's going to be the plan. But beyond the Q&A section after the presentation, I also want your feedback. We have launched a new survey where you can give us your thoughts and opinions on our virtual Science Cafe program. Do you like it being on Thursday night? Is 7 p.m. a great time? Do you like my hair? All questions that you can leave. Okay, not the hair one, but we do want to know your feedback and thoughts on our program because we want to make sure that we're bringing you the best science content that we can. So we're going to be dropping the link. It's right there on the screen. Visit the link, fill out the survey, help me out so that I know we're giving you the best show that we possibly can at NCMNS. Now, on to the show. I took care of the housekeeping and the announcements. On to the show. We do have a cool program for you tonight. Something that when I saw the guest speaker, when I saw what the topic was going to be and, got the abstract for the program, I had to go do some more reading on the side because the concept of building tall buildings out of wood just didn't quite square with what I have seen in the past, right? I'm thinking, okay, big buildings need a lot of really rigid structure. Steel is what you need for that, right? And I was even thinking and you can do this at home right now. Think about a tall building in the future. Think way out in the future. Do you imagine that building being made out of wood and wood products, right? In my mind, no. But in the mind of tonight's guest speaker, yes. So I'm going to go ahead and bring him into the show. Tonight's guest is a wood products extension specialist with North Carolina State University, Frederik Laleicke. Welcome to the show.
Good evening, Chris. Thank you for having me here tonight. It's a pleasure meeting you, and good evening to all of you at home and wherever you are.
Yeah, thanks for joining us and getting ready to teach us a little bit about tall wooden buildings. Have you always been thinking about tall wood buildings?
It's complicated, Chris. It's complicated. So let me tell you this. When I was a kid, my brother and I, we used to go into the woods frequently to build tree houses. Okay. That's the thing. My brother, well, he started about 10 feet off the ground and built, 3 stories. I started off the ground maybe a foot, and I completed about 1. I think I made it to 2 stories twice. At that time, I had no idea what we would be able to do with wood today.
So you have been thinking about this for a little while, at least.
Yeah.
It runs in the thought process and maybe in the family. Well, I think it's time to jump in. Hope everybody's got their thinking caps on. Take good notes. There'll be a quiz at the end of the show. Okay, not really, but let's get ready and learn something new. Frederik, I'll turn the show over to you.
Thank you very much. Let me quickly share the screen. Is that the right one? Is everybody seeing the right slide?
That is excellent.
Perfect. So again, thank you for having me here tonight. I'm really excited to talk about tall wood buildings and tell you a bit about the technology and how we make woodwork for those type of applications. You don't have to be from North Carolina to notice that I'm not from here. I'm originally from Germany, and I came to the US at the end of 2012. And when leaving Germany, many people were asking me, hey, Frederick, what is it you find so exciting about the United States? And had I had these numbers at the time, I would have told them, hey, 90% of the single family homes and about 77% of the multifamily homes and 71% of the multifamily units completed in those homes were framed in wood. Now, of course, I didn't have those numbers at the time, so I simply told them, hey, in the US, I don't have to convince anyone to build a home out of wood. Isn't that exciting? And then I came to the United States, and shortly after arrival, I learned that a whole network of scientists, engineers, and industry folks is working on a technology called mass timber. And I had heard of that before, but I had no clue they would be pushing the limits to build tall wood buildings. So let's take a closer look at wood construction in the United States. If you take a walk outside, maybe down the street to the next development, you are likely going to see something like here on the left, light wood frame construction. I think that's the most common type of construction in the United States using wood. You use dimension lumber, composite panels, and a few engineered wood products to build single and multi-family homes using this technique. There's another technique, another construction system called post and beam. It originates actually from the timber frame construction that was done in the old days. Post and beam uses larger pieces of wood, solid wood, some engineered wood products can be used as well. And it's primarily used for upscale construction or upscale buildings. In recent years, it became really popular with small to mid-sized commercial construction. If you take the two, light wood frame and post and beam, and combine them, you get to mass timber. And what that is, well, let's take a closer look. Mass timber is actually a whole group of different products. At the top left, you can see nail laminated timber. So a whole array of dimension lumber, long pieces of solid wood are connected using nails. This type of product is mostly used for floors and horizontal applications. Then there's dowel laminated timber. And as the name says, the pieces of wood are connected using dowels. From a wood physics point of view, this is actually quite interesting. So these dowels, hardwood dowels, they are dried to a really low moisture content. They are then inserted into these holes, and as they gain moisture, they expand and they form a really tight joint. On the right, we have the infamous, newly invented, it's a brand new product, mass plywood panel. It's actually made by Frederik Lumber, a company in Oregon, and it's made out of veneers glued together to form a large panel. At the bottom left, glue laminated timber. This product has been around for quite a while. It's really popular. Next time you come to the airport, RDU airport, take a look at the ceiling. There's a lot of glue laminated timber, GLT, right there. And then in the center at the bottom, cross laminated timber. That's really the most popular products among the group of mass timber products. And well, let's take a closer look. So as I've said before, cross-laminated timber is made from dimension lumber. Pieces typically 4 or 6 by 2 inches wide, wide and thick, 6, 8, or 10 feet long. Next time you get to your local building material supply, take a look. You're going to see something like here on these images on the left. We then take this dimension lumber, we combine it to layers, and then we take these layers and put them onto each other, alternating the direction of each layer by 90 degrees. And eventually, we get a panel that can be between 8 to 12 feet wide, 20 to 60 feet long, and 3.5 to 9 inches thick. But before this panel leaves our factory, we can do something else. There's an additional step. How about cutting openings for doors and windows into those panels? Or maybe an opening for wiring or plumbing or something like that. When that is done, we put the panels on a truck, bring them to the construction site, and with just a few people and a crane, we can immediately start setting up the building. Construction is quick and fairly easy to facilitate. So, mass timber, CLT, well, it was made in Central Europe in the 1990s. Austria, Germany, and Switzerland. In the area of these countries is the origin of CLT. And the idea at that time was to really find a more efficient use for small pieces of wood, side products from the sawmill industry. And those low-value components were combined into a large panel to gain additional value. First accreditation for CLT was given to KLH, Massivholz in Austria, and Merck Holzbau in Germany. And today, the largest manufacturers for CLT in Austria are actually Stora Enso, a company with headquarters in Finland. And I have to mention that here because our department head is from Finland and he's probably watching. Binderholz and KLH Massivholz. A fun fact about KLH, you would typically think that these three letters stand for some kind of a family name or so, but it's actually the Austrian equivalent to CLT. KLH stands for Kreuz Lagenholz, cross-laminated timber, CLT. So how about mass timber projects in the United States? You can see this map on the left. We have a huge number of projects in the design and also in the construction or construction phase, or well, already built and finished. A high concentration on both the West and East Coast. And there's this table at the center of the slide. CLT is obviously the most popular product used. NLT and DLT, nail laminated timber, and dowel laminated timber are not that popular. Then there's heavy timber decking. So heavy timber decking is actually used in horizontal applications for flooring and roofs. And it's basically a single layer of timbers joined by tongue and groove. It's a very I've talked about that, also really popular. So we have a really nice landscape of mass timber activities all across the US. Some of the companies here to mention, D.R. Johnson in Oregon, Riddle, Oregon. It was the first company to achieve certification for a domestic CLT product. SmartLam working out of Montana, and StructureLam actually home to BC in Canada. So why all this? Why mass timber? Well, there are a couple of reasons. Let's look at the environmental side. Wood is a low carbon alternative to steel and concrete. There's something called carbon sequestration. We'll look at that in a second, and it's a renewable resource. On the economic side, well, that's also an interesting aspect. So the financial burden, the financial aspects, or the necessary investment to set up a CLT construction is actually moderate. And since it uses the existing industries of dimensional lumber, we should be able to tie a CLT industry directly into this existing dimensional lumber industry in many of the villages and towns and places across the United States. On the construction side, reduced labor costs. We don't need many people on the construction side. Everything is pre-manufactured, so we can set up the building quickly and we don't lose a lot of time. There's also a high compatibility with traditional and innovative construction systems. And Well, I'm a wood guy, but honestly, I'm a fan of hybrid construction. I like to use concrete and steel and combine them with wood to achieve the best result possible and use each of the materials to their advantage. The well-being of wood is perceived healthy, and it's appealing, it's innovative, and eventually indoor emissions, that's an important topic. Using wood, we can really keep those under control and be in compliance with emission goals. Let's take a look at the carbon sequestration, carbon release and carbon sequestration. The idea is that as a tree grows, it absorbs CO2 from the atmosphere and stores it as carbon in the wood. This is an important topic today as we are looking at climate change and increasing levels on CO2 in our atmosphere. So the tree grows, it reaches a certain age, we harvest the tree, we take the wood, we turn the wood into a product, we go to a construction site and we build a house, some type of a building. We use the building for, let's say, 50 years, and then we take down the building, we dispose of the wood, it will decay, it will deteriorate, maybe we convert it to energy, so we burn it, and all of that carbon that was initially sequestered is returned back to the atmosphere. I know this sounds really nice, it's a nice story, but it's only half of the truth, and there's a little bit more to it. On the emission side, it's not just the wood. There are potential emissions during harvesting, during production, even the construction phase. Maybe we burn some gas to run a chainsaw, run a machine or something like that. Then the use phase of the building. The use phase of a building is known to create a lot of emissions. And depending on the type of product we use, we might have advantages or disadvantages in terms of energy use and emissions. And then there's the end of life that might even cause additional emissions. But on the positive side, how about practicing sustainable forest management, where we try to balance the economic, ecological, and the social functions of the forest? And we try to preserve all these functions and the forest for future generations so we can continue to get wood as an important building material. And then, well, think about this. The typical age of a tree in North Carolina when it gets harvested, a pine tree, is 27 years. So while we use this building for about 50 years, we can plant and harvest 2 more trees at that time and sequester more carbon and take it out of the atmosphere as long as the wood is in use. I think that's a good approach. So let's finally take a look at a tall wood building. Albina Yard and Framework in Portland, Oregon. It's the first commercial building to use domestic CLT, completed in 2016, 4 stories, 16,000 square feet. It was built in a very tight neighborhood of Portland, small roads, many buildings, and just using a crane and a truck, they were really efficiently able to quickly finish this building. What I like about this building, when I read about it, is actually a comment from one of the architects. If you want to prepare a great meal, you use what is local or what is in season. It's not just about what you want to create. It's about what's actually available to you and how you turn that into a transformative experience. What if we, here in North Carolina, for example, what if we were able to use the resources in our backyard and put together a project like this? Wouldn't that be great? I think in today's time, this has a lot of value. This is a tall wood building. Well, here's one a little taller. University of Arkansas, Adobe Hall, the Cherokee word for woods. They claim it's the largest CLT building in the United States. It's their sustainable way of re-imaging campus housing in contrast to traditional housing. And I think it's a great example of a dorm. It's very attractive. 5 stories, 202,000 square feet, 708 beds. It used 3,200 cubic meters of CLT and about 1,100 cubic meters of GLT. And I think they found a really good solution to create a dorm that is appealing and attractive to students. If you look at the bottom image, isn't it great how they combined wood with other materials to create this type of a learning and living environment? I think I would like to be a student there. That would be a nice thing. Well, this is a taller wood building. Let's make it a little taller. UBC Brook Commons. It was the planet's tallest wood building for 1 year. The University of British Columbia set up this building, I think in 2017, yes, the August of 2017. And after all of the components were pre-manufactured, it only took 70 days of assembly to finish the building. It's built on a concrete podium, and it has 2 concrete staircases. You can see them on the top image. One of them is right next to the crane. It has space for 404 students, single bed to 4-bed apartments. And one thing I really like about this project, so if you look at the bottom image, you can see the floors are made out of CLT, the columns are made out of glue laminated timber, and then they have these elements there with the window in it. All of them were pre-manufactured, brought to the construction site, and then mounted. And now think ahead, maybe 20 or 30 years. In 20 years, maybe we have better windows, better insulation, maybe we have other standards regarding energy efficiency. So we can replace those. We can take out the old window elements, put new ones in, and extend the lifetime of the building by maybe another 20, 30, 40 years. I think that's a really, really interesting approach. 18 stories. Well, what do you think about fire? Could that be a problem? I know at least tonight's viewers from Raleigh have some experience there when in 2017, the future metropolitan apartment complex in downtown Raleigh caught fire. I looked at some photos, I read a few articles, and that was really, really, really impressive and amazing, and not really nice to see. But the fire department made an important comment in the news articles. This was a construction site. And there's this short period of time, 2, 3, 4 weeks, when all of the things we can do to make a wooden building fire safe were not in place. The IBC, the International Building Code, basically has 3 factors or criteria for fire resistance. One is the structural resistance. It's the duration the assembly can support its load during a fire event. We want to have enough time to get everybody safely out of the building. Then there's integrity, whether the assembly can prevent the spread of high heat flames and gases. We want, if there's a fire, we want the fire to be contained in a limited area, so the fire department can efficiently take care of it. Then insulation. Prevent temperatures on surfaces not directly exposed to flames from rising above pre-fire temperature. To light wood on fire, you don't need a flame. A high enough temperature is enough. Interestingly, thick pieces of wood, so mass timber, shows an interesting behavior. In a fire, the char from the fire forms on mass timber at a predictable rate, slowing combustion while retaining strength and allowing time to evacuate the building. If you look at the image on the left, you can see that after a fire, this layer of char has formed on the surface of this CLT panel. And what it does is it insulates the inside from high temperatures so that the cold wood remains intact. It remains strong enough to keep its structural integrity, which gives us more time. If you look to the right, you can see a drawing. This drawing is from the Brook Commons building. And I included this drawing here to show you what other things we do in these tall wood buildings to keep the building safe from fires. The columns, one at the top, one at the bottom, the floors made out of CLT to the left and right, all of them are covered in 3 layers of gypsum wallboard. So drywall basically, to protect, very well protect them from high temperatures. There's a steel fixture in the center that holds the floors and those columns, and it's very well insulated on the inside of this assembly, protected from high temperatures of a potential fire. And then, of course, there are sprinklers. They're certainly required in wooden buildings, and many other things we can do to make the building fire safe. Next time you go online and you look for mass timber or you look for cross-laminated timber, you might come across something like this. I call them tall visions. One example is the Canada Earth Tower. It's the idea of creating the world's tallest hybrid wood tower in Vancouver, BC. 40 stories, 339 square feet, 200 residential units. The idea is to create it with a concrete core and the rest is wood. They aim at achieving passive house certification, so a standard to keep energy consumption really low, make it really efficient. Zero carbon is another approach there. And one of the things they have included, you can see that at the bottom, is to have these interconnected social spaces that offer an immediate connection with nature in clusters of 12 to 18 households. So a lot of functionality there, a lot of ideas. The question with all these visions is, what is the rate of diffusion from a vision to a real project? There are quite a few projects you can find online that, well, they've been stopped, they've never been started. But it's interesting. Maybe in 10 or 20 years, we'll see something like this in reality. And I'm really excited to see that happen. Enough about visions. We at NC State, Wood Products Extension, we decided to do something with CLT. We are working on a project funded by the US Forest Service Wood Innovations Program, where we look at developing cross-laminated timber panels for residential and smaller commercial construction. And what's interesting is, to make these panels, we use the type of cold press used in our former furniture industry. So we can reuse these presses and use an existing resource. The type of wood we use is southern pine, which grows in our neighborhood, in our backyard. And we make small panels 4 by 8 feet. We have partnered with a big number of companies all across North Carolina. And this is an ongoing project. And I'm really excited to get back to campus soon and see our new press, the one in the center, the red press. It was delivered about 1 or 2 months ago. Never seen it, never had a chance to get to campus, but hopefully by August, we'll have a chance to make some CLT. Well, this was really quick. I'm sure you have a lot of questions, you have a lot of comments. Anyway, feel free to contact me at Wood Products Extension if you want to know anything about wood. We have a website, I have an email address, and I'm looking forward to talking to you. Thank you very much.
Yay! Thank you very much. Excellent stuff. Very, very interesting.
Thank you.
And having looked up some of the stuff beforehand to, try to get ready for tonight's talk, I had seen, pictures, and so even I think I saw some of the graphics maybe that on CLT that you showed there. And that was not how I had pictured wood being used for tall buildings, making enormous panels out of it, or, huge, big structures. In my brain, I'm thinking, like, how many 2x4s does it take to make an 18-story tall building? But that's, of course, it's so much more complicated and better thought out than I would.
It's certainly a technological advancement. The ability to control and build something like this out of a natural material, a renewable material, wood. I think that's quite fascinating. Yeah.
So I'm curious, and I'll remind folks, put your questions, comments, thoughts in the chat boxes in the comments, and we'll grab those and I'll pose those questions to Frederick in just a moment. But it seems like if we started to move towards wood buildings, beyond residential homes, we would need a whole lot more wood products. Where would all of these wood products come from, such that it would still be sustainable?
You're making a good point. So this question comes up quite often, and there are a few aspects of a response that I would give. One is in the so-called production forests. So those forests that we use to grow and harvest wood for these type of applications, we are actually at the moment growing more wood than we are harvesting. So the so-called wood basket is fairly rich. Then the idea is not to build everything out of wood. I wouldn't do that. There are certain types of buildings where CLT is just not efficient, but there are other types of building where it makes sense. Sustainable forest management, I mentioned that this is really important. Nobody's really talking about cutting old growth, so old forests, clear cutting them to get enough wood for this type of construction. That's not the idea. And then, and I think unfortunately I skipped that in my presentation. What about recycling and reclaiming wood? What about building a building, using it for 50 years, and then taking that wood and using it for another building? This way we would need less wood and we could still accomplish wood construction.
Okay, excellent stuff. I'm going to turn to our chat boxes, see what folks are thinking. All right. So Kim has a question. Kim says 7 days to assemble is amazing. Was it 7 days or 70 days?
So the UBC Brook Commons building, that was 70 days. And the important thing here is that was after everything was pre-manufactured off-site in some kind of a factory. Gotcha. And they only had 8 or 9 people on site. So a really small crew to assemble the whole building, extremely efficient.
So and Kim has a question too. Is this type of laminate wood prefab construction available for houses that would be LEED Gold or even Platinum certified?
Yes. So the original idea of CLT, and if next time you travel to Austria or southern Germany, for example, it was originally designed for single family homes. So you would maybe use it as a floor in the home and build the rest using concrete. So that's, I think, the origin of this type of material. And then time after time, people started using it for tall wood buildings. At the moment, I have to say, there is manufacturing or production of CLT in the US available, but at the moment it might still be a little costly or cost inefficient to build something like this in Raleigh when you have to haul the CLT from a production facility relatively far away.
Which would add to some of those carbon costs as well.
Exactly.
Right? Yeah. Okay. Ali is asking, would it be possible to make a wooden skyscraper? So you showed us a vision for 40 stories.
Yes.
Can we go bigger?
I think we can. Why not? I mean, the building code, of course, has limits, and we are not there yet. I don't know where the limitations would be. Is wood strong enough to do that? Probably. I think we can go higher. Do we want that? Maybe.
Oh my goodness, more questions than we have answers. Okay, Katie is asking what kind of wood is used? Is it all southern pine?
Well, here in this region, we use southern pine, softwood. So the typical wood for CLT is some kind of a softwood. I know on the West Coast in Oregon, they use Douglas fir. In Austria, probably some firs and spruce. It's what's available. The softwood that is available. I'm not so sure about hardwoods. I know some people have done tests, and maybe some hardwood-based CLT panels are available, but the majority is softwood.
Now, Katie mentioned, posted a comment earlier that the dowel laminated wood seemed like a neat innovation. Why focus on CLT instead of some of these other types of wood products?
So if you recall the slide, both dowel laminated timber and nail laminated timber, all the wood was in one direction, and you didn't have multiple layers of wood on each other. So if you look at the mechanical properties, they will definitely differ from a cross-laminated timber panel. And that's a big difference. I'm not so sure about the overall strength of a dowel laminated timber panel compared to a CLT panel, which uses a structural adhesive. There are probably differences. So that maybe explains a bit why we use more CLT than NLT or DLT.
Now, Linda, watching on our live stream channel, has a good question too. Are there issues with outgassing?
It depends.
It depends. Okay.
It depends. So VOCs in indoor environments is certainly a question. There was a big discussion about formaldehyde some time ago, which came out of composite panels using adhesives that off-gas formaldehyde, but through very stringent certification systems to control these emissions first on a state level in California through CARB, and eventually through the EPA, all of this is under control. I don't know how it is with certain wood species, how they impact the indoor environment, but I doubt it's that bad.
And Linda continued on with a couple of questions about the sort of building process. Linda wrote, still use 16-inch centers on 2x4s, and how do you use bats of insulation? So I imagine using CLT really changes up how you construct a small or a large building.
So CLT is not everything you use. In this case, you would, on the outside of the building, you would typically apply some kind of insulation, then have a little air gap, and then some kind of a siding or cladding. Adobe Hall, so the building at the University of Arkansas, what they did is they have a cypress siding on the outside that gives the building a grayish color tone, so makes it quite attractive. There's a lot of building science and building technology in addition to just the CLT.
Got you. All right, there's more questions rolling in. Let's see what we've got here. Oh, they're coming in too fast. Is bamboo ever used for laminated timber panels?
There might have been some projects using that, but I'm not too familiar with them. I know there's
decorative stuff with bamboo, right?
Well, you can buy bamboo flooring. You can buy utensils made out of bamboo. But yes, flooring, of course, is available. There are also a few composites, so composite panels available made out of bamboo. I know of a guy in Vancouver, BC, met him a few times. He actually recycles chopsticks, bamboo chopsticks, glues them together and turns them into decorative furniture. Quite an interesting approach. But I have not heard of bamboo being used for these type of applications here.
All right. Glenn asks, what about earthquake and hurricane resistance and durability?
The nice thing about wood and these mass timber products is that they have a fairly good weight to strength ratio. So to achieve a certain strength, I need an amount of wood that is fairly light compared to concrete and steel. So in terms of earthquakes and the mass that is accelerated, I'm in a somewhat better position. That's what I know about earthquake safety for these buildings. The other calamity you mentioned were hurricanes or winds, I would assume it's similar. But tests have been done. I know of a colleague of mine from Oregon State University. He did earthquake tests of CLT in a test center in San Diego a couple of years ago. We watched that live on a live stream. I recall that very well, and testing has been done, and it's deemed safe.
Excellent, excellent. Let's see here. Kim wants to know if you've ever watched the YouTube hydraulic press channel.
The YouTube hydraulic press channel.
I think Kim maybe was impressed with some of the laminated wood machines.
Yeah.
In the extension office.
Let me just write that down.
Yeah.
I have to. I'm sorry. I have to write that down.
Although I think on that one, it's more about squishing things till they break instead of assembling things to not break.
Watermelons, baseballs, those type of things. I think
and
I've
beyond.
seen that. Yes. Okay. I'm familiar with that. Absolutely.
Let's see. This is a good question here. Where and what would be the most innovative use of wood construction happening in North Carolina?
Yeah. The most innovative use.
It's got to be a building on NC State's campus, right?
That would be my dream, to be honest. To have a building here on campus where we can show the technology, we can show what can be done with wood, we can use it for education, we can use it for research, something like a living lab. That would be nice. I'd be happy to start with a small thing, maybe a bus stop. I've been thinking about that for quite some time. A bus stop is a good thing. It's small, it's fairly easy to design, but you have a lot of people come by so they can see it, they look at it, and they come by every day, and we can test it outside. Wow. So maybe a bus stop. Maybe a bus stop is the most innovative building to be built in North Carolina at the moment. Maybe. No.
You said the leadership at the extension office might be watching, so we're planting ideas.
Absolutely. Oh, everything's strategic here. No.
Okay. Glenn says that I think this construction would have very good insulation properties. Is that true?
As far as I'm familiar with it, I've looked at it. The so-called R value, which is an indicator for the insulation efficiency of a material of wood, is actually pretty good. And if you think about it, any material that has a lot of air pores in it is deemed a good insulator. So wood, yes. But you would want to have some insulation on the outside to really achieve today's standards of energy efficiency.
Nice. Okay. Let's see. We talked about earthquakes. I think we got Penelope's question there. Let's see. Penelope had another great question. If a laminated wood product burns, what pollutants are generated?
So what kind of pollutants are generated? Well, you have the CO2, of course, which is emitted. The process of fire and wood. So as wood heats up, it decomposes and it releases a gas. And this is actually, to my knowledge, what burns, what creates the flame. In addition to that, you're probably going to have a lot of residues and other things, maybe tars or other chemical components. And I'm walking on thin ice here because the chemists in my department, they know a lot more about it than I do, I have to admit. So yeah, it's probably not healthy what is emitted when wood burns, but yeah.
So you talked a little bit about fire, and it was amazing that you mentioned the 5-alarm fire of the Metropolitan Building downtown Raleigh. I have video on my phone of that fire because it was a Thursday night after a science cafe. I had nothing to do with it, but I walked outside of the museum and saw the whole thing. And that was that picture is burned up here because it was really incredible site. But you discussed fire, and I believe you on what you said there. But what about other issues that people see in buildings like mold and moisture problems?
That's a good topic you're bringing up. Of course, you have to protect the wood. Wood and moisture, especially when the moisture content, the amount of water in wood reaches a certain level, certain moisture content, it becomes attractive to fungi and other microorganisms that can cause troubles. So you want to protect the wood. I was on a project a few years ago where we, at my time when I was still at Oregon State, where we looked at the construction of a CLT parking garage. Now think about a parking garage. That building it's basically fairly open. You have a lot of cars coming in and going out. It's Oregon. It rains about 6 months of the year, basically without interruption. So we were looking at how can we make this building safe? And the result was, yes, we need maintenance. We need to monitor the building regularly to make sure it's safe. But we also need techniques to protect it. Coatings, coverings, those type of things. And you would do the same in a wooden building, of course.
Okay, now Linda watching over at livestream.com, this is a great question and one that especially people in the Southeast will be familiar with. Termites.
Termites, same thing here. You have to protect the wood. I mean, if you look at the building codes, you will find that the wood will be protected in various ways. So you will avoid any type of ground contact. There's also the possibility of treating wood. So treat wood that is in, let's say, dangerous areas, so closer to the ground than other parts of the building, that could be treated, or that has to be treated. So there are various ways to protect the building. You will not simply take CLT, put it in ground, expose it to moisture, microorganisms, and let it be a good home to termites. That will not happen. But it's important to think about that. Absolutely.
So what do you think are the barriers to more designs with wood products like this?
Yeah, certainly at the moment, cost. You cannot buy CLT products, panels products everywhere you want. So logistics create costs. That's certainly an issue. Over the last 8 years or so, or let's say 3-4 years since the Brook Common building, if I remember correctly, that the cost of that building were already fairly close to the cost of steel and concrete. They had brought down the cost significantly. And I think that trend has continued. So that's probably solved. What else? Maybe you have to be an innovator. Maybe you have to be the person that takes the first steps, that is willing to take a little risk and not go the ordinary way and do something different. But it's being done. And I expect it to happen soon in North Carolina, maybe in Raleigh or Charlotte as well. Yeah. And it's the same in science. When the first people started doing research on CLT in the US, some people were maybe smiling at them and saying, oh, okay, let's see where that goes. And today it's one of the hottest topics among researchers, in wood science researchers in the US, if not globally.
Why do you think CLT and these wood products got started in Europe first? Was there something particular about the markets there, or research there, versus, say, here in the US?
Well, I mentioned during my presentation that one of the initial ideas was to simply find a use for side products. So you make a main product, and then you have these small pieces of wood, and you don't know really what to do with them. Do you want to burn them? You want to throw them away? So then one person had the great idea of combining them into a panel. And so you eventually turn a waste product into a really, really valuable end product. And then if you think about southern Germany and Austria, they've always liked wood construction a lot. And I think it was the right thing at the right time.
All right. Well, I think to close things up, it looks like we had lots of NC State forestry alum watching the show tonight. I hope they had fun. That's awesome. Thanks for tuning in, everybody. And Frederick, thanks for being here. Thanks for sharing your knowledge with us.
I've wanted to do something with the museum for a long time, and thank you for this opportunity.
This was so much fun. I learned everything new. I knew nothing about this. And that's what I love about getting to be a part of this program is every week I get to meet interesting people doing interesting things. So everybody, thanks for tuning in tonight to our virtual science cafe. We will be back here next Thursday night, 7 o'clock, right here on the museum's YouTube channel. Next week, we'll be partnering actually with Connect Raleigh, the city of Raleigh, who are doing science and art installations around town. So the artist, Alyssa Miserandino, will be with us to talk about how she envisions some of these art projects, the work that she's done in the past, incorporating science and nature into these major projects. If you're going to be tuning in next Thursday, and I hope that you will, bring headphones because a lot of the work is sound and soundscapes and what's called binaural recordings, two sounds, like 360-degree sound recordings. So when you tune in next Thursday night, bring your headphones, earbuds, headphones, whatever you've got. That way you can take in the full quality of Alyssa's work. If you aren't so sure that you can remember next Thursday, 7 o'clock, all you have to do is subscribe to the museum's YouTube channel and then click the bell to get notified when we post new stuff. That way, when we go live, you'll get a little notification to tell you to come and join the program. So I hope that we'll see you there. And I want to remind everybody that we do have the Science Cafe survey up and live. So visit the link. I'll put the link in the chat box right now, in fact. Click the link, and we'll probably put it up on the screen while I'm saying this too. Visit the link, give us your thoughts, your opinions on the program so that we know that we're giving you the best possible show that we can. As always, follow the museum on Facebook, Twitter, and Instagram. We're at Natural Sciences on all three, and visit naturalsciences.org to see more great science stuff that we're bringing you all the time. The Science at Home part of our website is being updated daily right now with do-it-yourself activities, more videos for you to watch, and a schedule of upcoming programs and events. We're doing live events all the time, educational program, fun programming. You can play trivia on Tuesdays with me, or you can join in a free classroom activity that we're offering as well. So lots of great stuff happening. I hope that you will continue to be part of our big Science Museum family. And thanks for following along, everybody. Take care, stay safe, and we'll see you again next week here at the Science Cafe. Bye, everybody.